Great, it's an absolute delight to deliver the Hugh Bunting lecture, an inspirational figure. Historically, I mean, Google it, please see the character that he was and how he helped move things forward. In the same way, in all of your own countries, you'll help move things forward and change some of those paradigms. Paul, could I ask you to read out that statement, please?
All of it. So we're all screwed. So don't tell us that we can imagine sustainable agriculture, because the reality is it's too late to fix the land degradation crisis. We don't trust anyone who says we need to demand a livable planet because we don't have a choice.
Okay, put your hand up. Do you agree with that statement? You think indigenous peoples would agree? Great. Because there are a number of indigenous groups that read either from right to left or actually from bottom to top. And you have a bias, and we looked at it. Remember, we're trying to look at the world in a different way. And if you do read it from the bottom to the top, would you agree with the statement now? Okay, so just remember Hugh Bunting and how, as a pioneer in thinking, zooming in, zooming out, looking to the future, looking back, turning things upside down. If you can, throughout your careers, do that, you will succeed in whichever domain or sector you just try and work in. So I'd like to have a conversation with you this evening about 5 things. A quick history of agriculture in our world, the geopolitics of agriculture and land degradation and restoration, a little bit about the value of agricultural land, and lastly, some examples of maybe getting towards better land management. So, agriculture in our world. Our planet was a molten planet 4.5 billion years ago. It then went into an ice planet, and in fact, when that melted, the whole world was covered with water. There was no piece peaking above the water. It was all water. Our planet was once 100% at sea. About 380 million years ago, trees evolved, and it was trees that helped bring the CO2 from 4,000 parts per million to less than 200. And then 250,000 years ago, when early humans evolved, and 12,000 years ago, when agriculture started, 100 years ago, that real mechanization in the middle of modern agriculture. And to today, we still have subsistence farmers, and we still have issues of equity in societies dealing with those. So out of about 15 billion hectares of land that does poke out of the sea now, we have got about 4.3 billion hectares, 29% of the world's surface, that is in either arable land or rangelands and pastures to feed 8.4 billion people. And at the same time, we have wildfires, deforestation, drought, flooding, conflicts and war, biodiversity and climate refugees. We have a whole lot of issues to deal with at the same time as trying to grapple with that, what has often been called by many the food system crisis or the food crisis. So let's look at that total area of land that we have. Those are the 6 largest domains, land use types that we have. But of course, they don't appear like that. Proportionally, they look something like that. And there's a very thin sliver down at the bottom, which is urban areas. And of course, the world doesn't look like that. It looks like that. It's a mosaic. And it's fine if you're dealing with those red polygons, because it's all homogeneous and it's very easy to manage. But in reality, we're dealing with those blue ones, those mixtures and mosaics of different land use types next to each other. And when we cut and burn forest, and most agricultural land that we have today was formerly forest. So it's been cut and it's burned. And when you do that, that's the amount of nutrients we lose. It's not insignificant. it is not non-trivial. And it's always easy to point fingers at the tropics and developing countries and the global south. But look what happened in Europe over the last 3,000 years, where the proportion in those 4 columns there, take the last 3 columns and look at those sequences of how much of the arable land was forest and how much has been cleared. In Northern Europe, now only 1% of that arable land, or that land that was suitable to be used for arable, is now forest. 22% in Eastern Europe, and Central and Western Europe, only 6%. So we've cleared the forest. We've trashed the land. We've said we didn't need that because we need food to feed people. And when we get it wrong, it looks like that. And it can reach a tipping point, and it's really hard to reverse some of those things. I mean, look at the Aral Sea. So, and apologies that some idiot put that image in the middle there to obscure it. But in the 1960s, it was this huge lake. It was the 4th largest water body in the world, inland water body. And you can see in the bottom right, in 2014, how shrunk it had become. Those ships used to carry cotton. But now they are ships, literally ships in the desert. And when you look at that relationship between food and food supply and food security and land health, and here 2 parameters of soil organic carbon, so how much organic carbon there is in the soil, that thing that holds sand and silt and clay together, that thing that provides a platform for biodiversity to thrive, that thing that is a sponge when it rains so that water can be held, and the degree of erosion. And you can see there that the more soil organic carbon you have, the greater self-sufficiency, the greater food security that there is, and the less erosion, the greater food security there is. And that was done in 4 countries, Ethiopia, Kenya, Tanzania, and Uganda in East Africa, in about 600 sites. This is the most worrying slide I'll show you tonight. It's criminal, really, when you think about it. And those circles, those round dots, are children that died before the age of 5. They weren't stunted or wasted or having trouble at school. They died before they were 5. And the very dark circle is between 40 and 80% of children. And it correlates very well with the degree of land degradation, the poor health in that environment. So it's not just a tipping point or a benign thing. It really affects populations. And think about when things do go wrong, and we start to think, well, why? What went wrong? Now, I'm not sure whether turkey sandwiches are on the after talk nibbles or snacks. But look, just for a single sandwich, it takes 670 liters of water to produce that sandwich, a single sandwich. And if you're a person living in a small village carrying 15-liter container on your head, you've got to go back to the river 15 times in a single day for one turkey sandwich that you eat. That's the trade-off. But we don't like making those trade-offs. But please do go to the Foodprint website and start looking at your foodstuffs that you like, but that might also have a very large water footprint. And these are some total water footprint, blue water, green water, and grey water combined for a range of different foodstuffs. And look at those top 3: wheat, rice, maize. Also the 3 things that produce most of the calories we have. And food security used to all be about calories. and there were calorific deficits. But today we have more nutrient deficits. So really sadly, there are something like 750 million people who go to bed hungry. There's something like 3.1 billion people that are malnourished, including overnourishment. Let's come back to our landscapes, this place where it's all happening. So down the bottom of the valley, we're really concerned about soil erosion. And we've got to stop it, and it's difficult, and it's causing problems. But that process up in the mountains, the weathering, turning those rocks eventually into soil, eventually into a living medium, is what we call weathering. And where's the transition? I mean, the success of our planet was when we jumped from chemistry to biology. We had self-replicating chemicals that then became early stages of life, that then became this wonderful flourish of biodiversity we have. Biodiversity, I'll give you one fact about biodiversity. Well, I'll give you many more but later, but one really important fact. We spend $150 billion a year on protecting and studying biodiversity. 150 billion, that's a big number, okay? Slightly bigger than the new Tropical Agricultural Association project. Okay, 150 billion. But we spend 450 billion a year looking for life on other planets. 3 times as much. But we have this amazing treasure here, and yet we're not satisfied. Oh yeah, there must be something out there that's better. Remember, for every 1 degree rise in temperature, and we're talking about a 1 degree rise, a 2 degree rise, a 3 degree rise, well, I can tell you, if we get to a 4 degree rise, we're going to have a 4-letter outcome. 4-letter word outcome. For every 1 degree rise, there's a 10% increase in lightning strike. Now, how do you think the people in Lake Maracaibo in Venezuela feel about that? Already, they hold the world record. More than 300 nights a year, lightning hits the lake and the land around it. You don't need to sign up there saying, no fishing on the lake at night. So it's not just that it's getting warmer, but it's holding more moisture, 7% more moisture, 7% more flooding. And in this wonderful journey of understanding biodiversity, we kind of divide the world up. There's plants and there's animals, yeah? So plants, through photosynthesis, capture oxygen and carbon by chlorophyll and chloroplast. And at least mammals respire oxygen from the atmosphere using hemoglobin in their lungs. Okay, so chlorophyll and hemoglobin. Does anyone know the chemical formula for either of those? Oh, apart from you, Andrew, I know you do, but yeah, just keep it in your hat for a moment. Okay, photosynthesis, capturing carbon, respiration, capturing oxygen. That's the difference. That single metal in the middle of that complex compound is the difference between chlorophyll and hemoglobin. Plants and animals, so different. Stretch your minds, think about how, and then how we're shepherding that biodiversity and the interactions of that in the richness in our world. Topic number 2, the geopolitics of agriculture and land. Maybe it was because of my humor, maybe it was because of the organization I was working for, but I was invited to help broker a deal in the climate change conventions to bring land in, because it was kind of absent and it wasn't being talked about, and could we start having this dialogue? And in 2014, we had this technical session and it was brought in, but it was thrown out. Land is sovereign, it's too important. Don't let them talk about it. They tried talking about agriculture as a Trojan horse. We're not going to talk about land. And that's the perspective that pervades a lot of the intergovernmental meetings. And you can see why when you look at a political term on this scale, on this log scale of time, that political term is maybe 3 years. But ecosystem processes are thousands of years. A cropping season is a few months. And how do we reconcile all of those different times? Remember zooming in and zooming out in relation to trying to fix land or agricultural climate through a political lens. So where's the evidence for that, you say? So this is the word cloud from 1992, UNCED, the United Nations Conference on Environment and Development, the big Rio meeting. And in that big Rio meeting, this is the word cloud of the top 100 words that was in the 600-page document that came out of that meeting. Okay? And you can see how important agriculture is. It's not even there. And you can see how important land is. Oh, there it is. Insignificant. But don't worry, relax. Because in Agenda 21, okay, in Agenda 21, land was there. And we were going to do 4 things. Back in 1992, by 1996, we would have sorted out all of the policies for the best possible use of land and sustainable management of land resources. Fantastic. Okay. By 2000, we were going to improve and strengthen planning, management, and evaluation systems for land. Oh, job's almost done. Right. And by 1998, we were going to strengthen institutions and coordinating mechanisms for land resources. By not later than 1998. And also, stretch goal, we're going to create mechanisms to facilitate active involvement and participation of everyone. Okay, at the local level and decision making and land use by not later than 1996. Come on, let's have a clap for those people back in 1992. Just one small problem with that applause. We haven't done it. It's a nice plan. And that's this kind of conundrum that we face with land and agriculture and how we steward things. Where is it sitting geopolitically? So surely then, when we had the Millennium Development Goals that came out in the year 2000, it must have been there. No, land is not even in the top 100 words. Oops. But it's all right. By 2015, when we had the Sustainable Development Goals, surely it was there. No. So where is it? Why is it missing? Why is agriculture not there? Why is land not there? You're the bright young ones. You're the ones with all of your future ahead of you. Why is it not there? Why is it something countries, oh, yeah, we'll talk about it ourselves. We're not talking about it with you or you or you. Oops, it's backwards. So the SDG number 2, the one that is going to end hunger and malnutrition, achieve food security and sustainable agriculture. It's about consumption, production, and markets. But they are typically siloed. So we're not looking at the supply chain, we're just looking at the demand side or the supply side in isolation. And we're not going to achieve them. We still have 45 million children wasted. We have 148 million children still stunted, 733 million still hungry, 2.4 billion people with moderate to severe food insecurity, and 3.1 billion with no access to healthy diets. The G20 Global Land Initiative was about trying to make it a bit more tangible. You know, hey, what about if we only had to get 20 people in the room to agree? And amazingly, absolutely amazingly, particularly when you think about the timeline, Saudi Arabia convinced China, the US, Europe, Argentina, Australia, Mexico, South Africa, to come on board to doing something together. And it's amazing because they are 85% of the world's economy and most of the world's people. And colleagues, particularly Ravi Prabhu and Ermias and Huria at C4 and ICRA, helped put together for this initiative this plan of land stewardship and the land stewardship economy. And the strategy for the Global Land Initiative that is shepherded by the UNCCD, one of those conventions, is around conserving land, sustainably managing it, and restoring it. And it looks at the economics, it looks at principles, it looks at capacity development. It really is worth going to check out because it is some hope, some bright light of being able to turn around that kind of almost invisibility of land in international process. But you're a clever bunch and you want evidence, okay? So go to Google and Google land degradation. Put it in quotations so that it's not land in one paragraph and degradation in another. There's 6.2 million URLs that mention land degradation in that order, in that sequence. And there's about 10% that measure land restoration because we love talking about the negative stuff. And what we need to do is help flip that. And you're the ones that can do that. Let's get going. You know, we know how much land degradation there is. We don't need to cite it again. Let's get going on land restoration. Now, I kid you not, this is, I did the search myself. Look at the drivers of land degradation, 304,000 URLs. There's only 4 URLs that are the drivers of land restoration. Get publishing. You'll be a leader in that field. But everyone likes the bad news. Well, not that we don't like the bad news, but it grabs the headline. And we've got to help flip that when we're looking at agriculture and how we value it, remember? And the goods and services that come from it, the benefits to humanity and others. And so to our first topic, the value of agricultural land. And this is something we're working on as well, of trying to say, well, you know, land has an economic value, an ecological value, a social cultural value, a services value, and an intrinsic value. And how can we develop a framework that enables us to look at all of those and not just that production agricultural piece of it? Okay, if the University of Reading, I know they've just bought a new 250 hectare piece of land, but if the University of Reading, Simon, where's Simon? Okay, how much would it cost to buy the world? So tomorrow, if some extraterrestrials came down and said, we like your planet, we'll give you a good price. We'll pay in gold or cash or whatever you want. How much is it? What would we sell it for? It's us, it's our existence, our livelihood. Now, come on, how much would we sell? We're prepared to trash it, we're prepared to go right to the edge of tipping points, prepared to spend 3 times as much looking for life on other planets. So we have some intention of getting out of here one day. How much is it worth? Any ideas? Well, economists have looked at it. Unfortunately, there's no single land valuation approach, and so I've just given you an example of 7 here to look at. But I don't want you to become experts in the methods, but just think about it. What would we sell Earth for? And some put the value at $400 trillion, or about 4 times GDP. Seems a little on the low side. Others put it as high as 5 quadrillion, okay? Or 5 times 10 to the 15. Does that also seem a bit cheap? How much does that work out per hectare? So what is the value then? So when you look at the value of land, they ascribe 75% of it to land and property, that city, urban environment, and 13% to commercial property, and only 11% to agricultural land. I mean, as if it's more important to live on the 12th floor of a commercial building than to grow food. And so the United Nations Convention to Combat Desertification and the federal government of Germany are coming together to have a new exhibition to combine art and science, a 6-month exhibition starting in December this year, the 6th of December, and do go online and look at it, on uniting for land. How do we value, treasure, understand that? And the key audience for that is 10 to 12-year-olds. How do you explain to a 10 to 12-year-old all of that nuance that you've partially listened to today? All of that detail, all of that complexity. How do you, they've heard about the hole in the ozone layer. They've heard about saving the whale. How do we save land? What do we do? Do we all think it's important? We turned up to the lecture, so I assume you do. And it's an amazing exhibit. They've got these places where you can walk on the floor and see how by expanding in one area what you do to the water footprint and the food footprint and the energy footprint. Okay, to the last topic, and apologies for plenty of time. Towards better land management. So this is one of the best examples I've seen of land restoration, not land degradation. I'm not going to show you land degradation at all. I'm showing you land restoration. Okay. Remember, flip your mind, think about it another way. Okay, this is an area in northern Tigray, about 100 kilometers from Mekelle, and it is a place where after the Derg, and so the early 1990s in Ethiopia, the rainfall had been so poor, the vegetation was so poor, livestock had been rampant. It was a degraded environment. And so the government, with some aid donors, was saying, we cannot support people on this land. We're going to have to move them to urban areas. And they would move whole valleys, so like 20 kilometers by 10 kilometers at a time, into these places. And this group of people in this valley, they said, in Gigera, they said, we don't want to leave our ancestral lands. We don't want to not have access to our land. We've got to do something about it. And with no money on the table, no financial capital, remember, you capitalists, no financial capital, it was social capital. And every man and woman agreed to spend 40 days labor free per year up in the watershed, planting trees, building check dams, building terraces, building gambians to stop further degradation, to be able to reverse that. They knew it would take 25 or 30 years. And 25 years after that, believe it or not, because of that social capital, that is the watershed. Birds are singing, you hear water rustling, and they knew that it was going to take 25 years, but they kept at it. It wasn't a quick flip the switch, hit send. It was, we've got to be on this journey to turn that around. It's incredible. And it was that social labor movement. And yeah, they needed a few materials and some help in understanding it, but they had the stretch goals. And they turned that horrible situation into something that is restored land. The water table went from 14 meters below the surface to 1 meter below. And therefore crops could be grown. Okay, let's jump to East Asia, to China. This is the world's largest volcanic rock phosphate mine in the world. Not sedimentary rock phosphate, as you see in Morocco, those big areas, but volcanic rock phosphate, largest in the world. Something like 90,000 hectares. And the company, this is not the state, this is a private company in Japan, had huge problem with villages around their mines. Yeah, surprise, surprise, polluted water, difficulty. And so those communities would sabotage equipment, they would cause difficulty throughout. And the owners came to our colleague, a China director, Eddie Krapp, and said, can you please help us try and fix this? And he said, well, yeah, if you'd agree to spend money on it. And they said, look, we'll spend up to $3,000 a hectare. What do you want us to do? Okay, when you're mining, keep the topsoil and the subsoil in different places. Don't leave it denuded. Once you finish mining, do it quickly. And then those people that you hate in those villages and a nuisance, give them access to it and let them own everything that they can grow. And it went from this to the next slide in 5 years, not 25, 5 years. And a lot of it was based around economy and finance and high value mushrooms. You remember in China, the mushroom market is $60 billion a year, just domestically. And it's possible if we have those examples, those showcases, and that belief. And when we look at the opportunity for land-based mitigation in different countries around the world, how agriculture and forestry and wiser land use can solve a lot of that problem we have of throwing all of that carbon up into the internet, into the international gaseous dustbin that we have. It's incredible. And I credit the European Union for their honesty in laying out their own scorecard. Just how much degradation had gone on in 60 years that led to a lot of the change, and David would have seen a lot of this in Brussels himself. Where's David? Of understanding that led to the European Green Deal, that led to a lot of these kind of almost some difficult things that are coming through in legislation now because of all of those challenges in Europe. And if Europe is struggling with it, how's the global south and how are other even global north country areas starting? So we have to deal with complexity. We need to boil it down to simplicity so that 10 to 12-year-olds understand it. But we have to find ways of dealing with all of that complexity and having a framework to understand things, to put it all out there, even if we don't have the answers or all of the evidence and information. So if we have human and non-human factors of how the geology and the climate and the water and the topography interact with all of the things that you see there. I'm told this is another question, if you want to take a photograph of that. Yeah, it's complex. Yeah, it's hard to get your head around. But that is the nature of what we're trying to solve and the challenges. And every little thing that anyone does is really important to contribute to that whole. And don't let somebody exclude you from trying to contribute. Okay, imagine we discovered a new territory, 75 million hectares, okay? 75 million hectares is an unusual number. Where did that come from? Well, if you multiply it by 196 countries in the UN, that gives you the total land area on Earth, terrestrial land area. So it's like the average country size. Yeah? So if we found this new bit of land and we were all in charge in this room and all of the people online, we were in charge of deciding how much agriculture, rangelands, forests, inland water bodies, urban areas, mining energy, private ownership, community access. How much would there be? What would our plan look like? What would our scorecard, our homework exercise look like? No country in the world has done that. It's all a bit ad hoc. It's all a bit random. It's all a bit like, well, let's try and see what happens. It's totally unplanned. We still want that to go on for agriculture. Is that why we have so much food loss and waste? And yet there is hope. There's more examples out there. This is an incredible maize variety that was found in Oaxaca, Mexico. They use in this village no nitrogen fertilizer, zero. And they have the most productive maize growing anywhere. And why? And scientists found out that this maize gives this exudate, this gelatinous exudate. And there happens to be a nitrogen-fixing bacteria that just loves it. And so the maize gives carbohydrate or sugar to the bacteria in exchange for nitrogen. So it's not rhizobian legumes or Frankia. It is these incredible new bacteria that are this technological advance that, it takes 8 megawatts of energy to produce 1 ton of nitrogen fertilizer. 8 megawatts. And think of how we can save that with technologies such as this. Capacity, and it's not capacity development. You're not developing, you already have capacity, all of you, whether you're from the global north or the global south. What the governments need to do and others is to mobilize you. And the African Orphan Crops Breeding Academy, what it helped to do was to mobilize that capacity. To take throughout, now 172 students are being taught through this academy to be breeding more nutritious crops, a wider diversity of crops, and getting away from the stigma with, oh yeah, my grandmother used to eat that, I didn't want to, or we just feed that to our goats now, it's not for me. A change in that. Remember, we're trying to flip things, we're trying to look at it from different ways. And when you look at the inequity, the differences of countries in the world between how much countries spend on research and development, the number of scientists that they have, the percentage of GDP. So OECD has set a target of 3% of GDP spend on R&D. And there's only 9 of the OECD countries that hit it. European Union set a target of 2%, and I think 10 or 11 have hit it. The African Union has set a bar of 1%. Not a single country hits 1%, it's 0.8. And remember, the economies are smaller. So the knowledge economy, evidence-based decision-making, using science to advance economies, it's really making it difficult for those countries. And so Pan-African approaches, Pan-Asian approaches, international cooperation is really needed. And it's great there's institutions such as Reading University, such as the Tropical Agricultural Association, to help stimulate that so that it isn't duplicative and inefficient in dealing with things. And helping build those public sources and private sources together, because in most countries, think about Japan, 80% of R&D in Japan is privately funded, only 20% publicly funded. In Africa, it's only 33%. In OECD, as an average, it's 50%. And in Africa, it tends to be going in reverse. It's reducing. And part of the reason is when we have these international meetings and we're talking about agriculture, for some people on the banks of the Niger River, this is what they mean by agriculture. Oh, it's not that big herd of dairy cows that produces 25 million liters of milk a year. Oh, that's the agriculture system. Okay. Or this woman in Peru, in Abu Kiali. She's one of the most amazing farmers I've ever met. When the river floods, and the river floods about 15 meters, 50 feet when it rains. And she'd been cropping the sides of the denuded bank because it's rich in nutrients, until it rained. And she put all of her livestock and all of her possessions and everything onto a raft and just started floating down the river. And she'll be on that for 6 to 8 weeks. And eventually she doesn't know where. She's going to end up landing somewhere else and start again for the next season. But her understanding of cropping and dealing with problems and pests and diseases, there's no extension officers out there. But her ability to farm that and manage it and do it, because it's a low density, but an incredible woman. And then we think about something like the $800 billion a year that is put to agricultural subsidies in the global north. And so science and technology and understanding and bringing the same approach that like the health sector does. So the health sector knows that there's 201 causal factors for human heart disease, 201. But they also know that 3 of those, smoking, high blood pressure, and cholesterol, account for 75% of heart disease. So what do? Their public awareness, their interventions, their investments and monitoring and their reporting, predicated on those 3 parameters. When it comes to agriculture, we like to invent standards and certification schemes. And so, I know, let's go for 201. No, we've got to pare them down. Let's have 121. Global Reporting Initiative has 450, 120 on biodiversity alone. You spend your life collecting the data sets before you even analyze them or use them. And so we've got to get smarter at taking that health approach to the health of land. And using AI and using not just the data and the columns you're using, but all of the metadata that you bring with it. And having people sat there in their pajamas eating Pop-Tarts at 2 in the morning, wherever they are around the world, writing code and helping decipher that. To bring out what's the generic signal we need to know, 50% of the information. What's the local context specific one, maybe 30%, and 20% is noise or error. Because if you just measure the generic, that's 50% noise and 50% generic. I mean, it's like a coin toss. By having more citizen science, more ability to capture these things on smartphones, and this regreening app from other colleagues, Torvagen and others, Mohammed at ICRAF as well, of helping build up these huge data sets. And there's something like 300,000 small-scale farmers now in East Africa using these. Inequity or inequality, which one is the one we need to address?
Inequity. Inequity.
Okay, inequality is the unequal distribution of resources. And inequity is the unfair unequal distribution of resources. And you're right, it is that inequity. And we see it between countries and in others. And part of the time is we spend so much time on these certification schemes, we're dealing with all of these landscape principles. But it is the landscape principles, the people dimension that we need to focus on. And your last slide, okay? At the end of the day, it's about data and management and evidence and messaging. And how can you take that entire seminar and explain it in one paragraph to a 10 to 12-year-old? And that is your task, not mine. Thank you for listening.